we have Mr. Priyesh Potdar coming right here on stage to explain scalability in generative AI. Let us welcome him with a huge round of applause.
The
Sir,
stage is yours.
all yours.
Thank you, Shreya, Anjali, Chinmay. And great to see high level of energy. Can we have one more round of applause, please? Thank you. It builds up and pumps up my energy as well. Thank you. Okay. So is this mic on? Can I switch to this one? Okay. I'll prefer this way. Okay. So first of all, thank you everyone for joining in. A very good afternoon, and I hope you guys had a good tea break. Let's begin, right? So as a few of the folks rightly pointed out that at PubMatic, we deal with scale. And when I say scale, just to give you an impression, we process 850 billion impressions per day. That's the scale that we are talking about, right? And we generate around 1.4 terabytes of data every day. But today is not about the scale as a theme, but we will be discussing about generative AI as a theme. So from concept to impact, because we have learned a lot, we have heard a lot about generative AI, we use it daily also. But today we are specifically going to talk about that how we can use this particular technology for building modern businesses, how to use this technology in an enterprise setup, wherein you have multiple teams, multiple people contributing. Let's dive in, right? So I think we have already covered introduction multiple times. I'll just skip this. You can connect with me on LinkedIn. Just search for Priyesh Potdar PubMatic. You will be able to figure out all the details. Okay. Let's deep dive into the agenda. We will be covering a brief about PubMatic, what it is, taking you through a quick overview of generative AI. Then we will be actually discussing the main topic, which is what exactly are the key features and points when we are building or implementing any solution for an enterprise using generative AI technology. Okay. PubMatic, I already talked about the scale, but we come with a mission. PubMatic is a publicly listed organization, NASDAQ PubM. We are an independent technology company maximizing customer value, delivering digital advertising supply chain for the future, right? So obviously, I mean, a lot of words. What it means is we are into digital advertising, okay? In the SSP sell-side platform, as we call it, we are the leaders in the market as per the 2024 Q4 statistics from the Forrester Wave, okay? And we are, of course, great places to work, 2024 certified. Okay? Now let's get into the main topic. I know you have all been waiting for. What exactly is generative AI? I'm pretty sure you might have already used ChatGPT and different tools also, right? So typically, if you ask something like this, write a 2-line limerick of Google developer groups for India, right? You get a very nice creative answer. I am not that creative, but definitely ChatGPT helps me in such things. In India, coders unite with a cheer. Google Dev Group sparks innovation each year. And that is absolutely true. Can we have a round of applause? I mean, this is the statement which is generated by ChatGPT. That also knows like what exactly is GDG, right? And you might have used generative AI in order to generate images. So for example, of the creativity, create a dog, but which is made out of wood, right? So you get images and you also get videos, right? Now create a video of the same. So you get all these technologies. A quick quiz, which platforms can I use for each of them? So for the first one, ChatGPT, okay, fair. Second one, someone called Sora, okay. ChatGPT, okay, fine. Any other specialized tool or platform which is exclusively for generating images? Midjourney, right? Midjourney, DALL-E model of OpenAI, right? And for video? Which one? Okay. Any other? Have you heard about Runway ML? Yeah, Runway ML is specialized into like generation of videos, right? Now, what exactly? I mean, because we are generating the content, that is why it is generative AI. But specifically, when I talk about the models, right? Typically, they are more trained into generating text, predicting the text, right? And how it all happens in the background, right? I'll try and explain it with a very simple example. Let's say whenever we say that, okay, I am going to give a word hi to an LLM platform, what exactly is happening inside? So LLM is nothing but a very, very big neural network, right? And when I say neural network, what it is, basically imagine that as a graph to which we are passing certain inputs. So this hi was translated by embedding layer into some kind of input, which they then traverse through all the layers, different layers of the LLM platform or model as we call, right? And then generates an output based on probability. So for example, if I say hi, there is a 85% probability that the response should be hello, okay? But someone would say hi T, which is also correct, hi tech, which is also correct, right? So what LLM does is it basically generates lot of different possible outputs, along with that some probability score, and then picks up the best possible response which can be generated out of the same, right? Now, why it is called as large language? Because I just depicted maybe like what 10, 15 cells here. We are talking about billions of cells, okay? Imagine that diagram which I showed you translated into a matrix, right? Because obviously we are engineers, we deal with data types, matrix and all those things, right? So what exactly is the model? When we say, okay, this is a 3B model, this is a 13B model, what exactly B stand for? So B is actually billions. So imagine that each of these cells, right, billions of such cells and weights in the same actually constitute and create one LLM model, right? So, I mean, obvious question is like, what would be the size? And I think Karthik rightly pointed out that why now, right? In the morning keynote session, he said that what is happening right now that the generative AI has picked up? Obviously, advancement in the hardware and lots of data which is available. And why do we need advancement in the hardware? Is because in order to process any information from these models, you need to put those models in memory so that GPU or CPU can work on them and then finally generate an output. And here is a very simple stat which will tell you like, okay, what is the scale of memory that we need in order to actually use an LLM model. So a very small model like 3B model, and believe me, this is the smallest one, 1.5 is the smallest one. This is still a smaller category, right? With a 16-bit precision, we'll come to that, what is 16-bit precision? It actually requires 6 GB of memory, okay? 9 billion, 18 GB, and if we go to the 32-bit precision, we are going to go to 32 GB, right? Which is huge amount of memory which is needed. And just to keep things in perspective, the GPT-4o, which I think you might have used through the chat GPT, that is a 405 billion parameter model. So imagine the amount of memory which is actually being invested, and that is why the companies like that needs billions of dollars of investment, and they build moat around it, right? Because that's very difficult to replicate. I mean, as an engineer or developer group, we can't actually run these models on our laptop. Definitely the smaller ones, yes, we can, right? Like the 3B, 9B, yes, it is possible, but definitely not a 405 billion parameter models, right? And let me just try and explain the complexity of this entire stuff, right? So for example, when we say that, in the previous slide I explained that we actually had one word which was translated back into the, what will be the next predicted word, right? And this process actually happens again and again. So for example, let's say I say query as explain LLM, it might just generate LLM is, and then again repeat the entire process in order to generate the next one. So LLM is Gen AI and so on and so forth, right? So this process, you might think that as soon as we progress, right, at that point in time, the speed of generation would actually go down. And yes, indeed it does go down, and that is why you would remember that initially the context window of model was really, really small, 4096, 2048, right? And over a period of time it has increased because now we have actually implemented a lot of caching techniques so that these kind of generations happen really, really fast in the larger context window, okay? Now, coming to the topic, what exactly these technologies used for, right? So typically, I think most of us have used OpenAI models, ChatGPT, Claude, Google Vertex, Gemini, we already saw in the keynote, right? And folks are building, I mean, Device really covered it really well, that what exactly you can build from generative AI platform. But these are also some of the use cases which people are typically using it for. Building chat interface for customer support. In fact, not just chat interface, automated calls are also now becoming really popular. Building a knowledge base and summarizing meeting notes, Zoom AI, Companion AI, you might have used it, right? So these kind of technologies are built on top of it. Now, as a developer, when we are building this, a very, I mean, like 10,000 feet overview view, that user is going to interact with your application, and most probably you are going to use some third-party API, like Vishal called it out, right? That it's a wrapper that we are building, wrapper, right? So although we are building wrapper, but they are built in really, really creative manner, right? And each team in an organization, right, they start to kind of implement use cases in this way, right? And over a period of time, what happens is, team A, let's say, implement this kind of solution. Team B also went ahead and implement their different solution, right, for some different use case, okay? And so on and so forth. So if you have lots and lots of team, what is going to happen over a period of time is, you have all these kind of challenges to solve across each and every one of user application. And these challenges include, like, error handling, right? If you are doing some kind of error handling, you have to now implement from user application 1 to n, right? Similarly, token management. Suppose that the OpenAI key that you were using got compromised, right? You generated a new key, but now you have to go back and update it across all the applications. Observability on usage cost, right? The next thing is, obviously, this technologies or whatever these things are built on, they cost a lot of money, right? You need to keep a tab on, like, what is the current cost and how you are controlling it. Moderation challenges. So for example, if some team, let's say team N here, forgets to implement proper moderation, meaning that someone is asking, let's say, tell me how to make a bomb, and it actually gives you a back response. Or maybe uploading some kind of really confidential financial information into a model which is then accessible, let's say, across the public domain, right? So these kind of challenges also needs to be controlled. Legal and compliance. Being in ad tech, I can tell you that compliance is one of the things that we are really fanatic about. So you have to kind of then implement all those controls across all the things, right? Then obviously not everything is available at all times, so you have to define fallback models, like, oh, if OpenAI is not available, go back to Claude. Rate limit, cost control, multiple models, and third-party services integration. So there are a lot of third-party services also, like Amazon Bedrock, Vertex AI, through which you want to kind of integrate your applications with. Now, what could be the solutions in order to solve this particular problem? So we still allow different teams to actually build their own application and use case. However, we don't allow them to directly communicate to OpenAI or any of the third-party APIs. Instead, we introduce in between, let's call it an LLM proxy, okay? This LLM proxy will then actually go ahead and talk to any of the third-party APIs, self-hosted models. And what is the advantage of doing all these is, basically, it will provide you observability at this particular layer itself. Like the LLM proxy, you can now implement observability, and none of these teams, A, B, C, have to worry about it. You only implement it once. All of these teams will actually get the benefit out of the same, right? Next is basically all the challenges that we have seen in the previous slide, all of them gets resolved at this common layer then, right? Okay. Now, obviously, you combine all these things and put one application as chat interface on top of it, and you are actually able to control entire communication which is happening within the organization on that particular chat interface. Reason it is really important is because sometimes what happens is, if the developers are putting, let's say, sensitive information in the chat GPT directly, right? There is a possibility that it may be used for some, may be exploited in some or the other manner, right? If you are actually implementing, let's say, chat interface for your own organization, you have the full control on what exactly is the information being sent outside to the third-party models or to the self-hosted model, right? And someone actually called out that you have to build really smart routing rules. That's all of that is baked in into this particular LLM proxy. Because it actually automatically filters out as soon as you upload an Excel that I'm not going to send out to third-party API, I'll only send it to self-hosted models, right? Which you can actually host in your organization. Now, doing this obviously provides all the information, all the necessary controls that we have seen, right? Now, let's also talk about very common use case which an enterprise implements is basically based on RAG. Who here knows RAG, what RAG is? Okay, anyone if they want to call out? Perfect, retrieval augmented generation, right? So what it basically does is that you take your knowledge base, in very simple terms I'm explaining, you take your knowledge base, say that, hey, these are my books, this is my literature, you need to answer questions only from this particular knowledge source, right? Very high level, very simple terms. In the background, what happens is, you can actually take this knowledge from all the data sources, put it into some kind of a processing queue in order to scale it well, okay? And then the document processors can actually go ahead, poll the queue, talk to embedding engines, and then store all the data in the vector store so that it can be used in the context, right? So whenever user actually queries, it has all the information about your organization from the vector store, and then give this entire context to LLM in order to generate the proper response. Now, while this is happening, why this is required in an organization is because ChatGPT doesn't know what's, let's say, PubMatic's marketplace offer, right? Apart from the public knowledge which already exists. In order to actually answer very specific question for a developer, like let's say, what are the limits which are there for the PubMatic marketplace? You can actually put in all that information in the vector store through the architecture which I explained and get the specific answer. Now this actually also what Vishal covered in earlier session was, you have to wait for someone else to answer the queries. Here you don't have to wait for someone else to answer the queries. You can actually talk to the chat interfaces which you have built, integrate the same, and then get the answers, right? Now, while you are actually pushing all those information in vector store, there are really some of the key points that you need to understand. We have learned it over a period of time, right? So content format is really important, specifically when you are talking about tables. Let's take an example. If you have this kind of table, right, and you generate information like this, order, details, price, Honda City 4-wheeler, blah, 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 right? This particular information, if you feed it to the vector store, you may not get the best possible answer, especially with the smaller models. Maybe with the higher models like 4.0 or GPT-4, you might be able to get required information, right? Versus what if you actually put the information in this manner, wherein you are actually expanding the titles of the row, the header of the table, and then putting the associated context, or maybe as simple as that, you are generating a YAML out of it. Transform a table into YAML and then feed it into the system, right? Now, I am specifically calling out YAML. Why not JSON, right? So, anybody knows what is the difference between JSON versus YAML, specifically in context of generative AI? Okay, I'll cover it very high level, right? So, in JSON, there are some additional characters, right? Curly bracket start, curly bracket end. And as I mentioned that these particular technologies work on token. So each and every token counts. So the more tokens you can save cost with YAML format as compared to JSON format. Second thing is, with the YAML format, you can actually give comments also, which is not possible in JSON format. So in YAML, you can actually say that object is Honda City, hashtag, you can put a comment hash, and then just give a description on what exactly is Honda City, right? This kind of capability is not there in JSON. The moment you do that, it becomes an invalid JSON, right? So these kind of things, if you actually take care of, along with the things or points which I mentioned, like handling of OCR, make sure that the context is always given, these particular things will actually improve your RAG efficiency many, many folds, okay? And I follow a golden rule. Whenever you are unsure about the content that you are pushing in the RAG, make sure that the content that you are actually pushing in RAG, you should be able to explain it to a person on a phone call who is not actually viewing your screen. So if I actually talk about this content, object is Honda City with details, I'll be able to explain it over a mobile to someone who is not looking at my screen. However, if I use the first example, this one, right? Probably if the person doesn't have any context, they will not be able to figure out what this guy is talking about, right? So these kind of very, very small things make a tremendous difference while actually building a REG, right? Second thing is where exactly you're storing this entire data. So always choose a data store which is allowing you for vector as well as scalar fields, okay? Let's take an example. So vector example could be that I am actually pushing in Honda City, four-wheeler and all those things. Scalar could be quantities like, let's say, cost. And if I'm putting a query like, okay, like this one, like search items with details containing automatic. So I'll be actually getting all the results with automatic, as well as I can sort them based on price. Because when you are only storing vectors, you cannot actually go ahead and sort based on same. So you are going to get a lot of results. You have to sort it based on the metadata which is there. And these metadata are typically the scalar fields, right? So always choose the vector database appropriately, okay? Obviously, the considerations are also that how are you going to scale in production? How many billions of records are you going to store there, right? So these considerations are also important, right? And lastly, you have embeddings and then you have LLM. Obviously, the building blocks of this entire discussions that we are having. I'm not going through the each and every point, but at a high level, let me cover this. So whenever we are designing any system, the first approach that, I mean, this is again a recommendation that you should rely on prompt engineering. And a good prompt engineering can actually solve almost, I would say, 70 to 80% of your problems which you are having with the model. A good prompt would actually contain this kind of structure. First of all, assign a role and a context, always, okay? So for example, you are a DevOps engineer who writes K8s deployment scripts. I have actually prepped my model to activate the neurons that you have seen in the first image, the neural network, right? So I have actually activated first part or maybe the relevant part of that particular neural network so that I get a better answer. Second thing is that your task is to take, and typically I have seen that people paste the entire content then and there itself. Never do that, okay? Always put a placeholder, because what is happening is you are actually switching the context unknowingly. That you are telling that your task is to take and then entire file content comes in. Rather, you should say that your task is to take something which is a Docker Compose file and then transform the same into Kubernetes deployment and services file as per the metadata provided, right? So here, use of placeholder is really important. And finally, obviously, make sure that you are putting the placeholder and the entire content of the file. This way, when you are actually writing a prompt, you are going to get really good results, okay? Next is training. If prompt engineering is not working well, go ahead and use the last resort as training. Again, in prompt engineering, there are a lot of different techniques. I just covered one, okay? So imagine these models as coming with a certain level of education. So for example, a kid in kindergarten may be equivalent, can be compared to a 1.5B model. Again, not a proper comparison, I am just giving logical comparison, okay? School-going kid can be a 3 billion model, HSC and so on and so forth, right? Why I am calling this out, right? Is because we have to pick up the best model or the best base model rather, because we actually in the training process what we do is we take a base model, we train it with our data and then use it in production. If you start with let's say 405 or 70B model, because I have GPUs and lot of money available with the enterprise, right? So what is going to happen is I am probably using a sword wherein a needle would be enough, right? So it's really important that start small. Make sure that you are building proper evaluation pipelines so that you know what is working well, what is not working well. And smaller models are easier to train, easier as in like, it will give you very, very fast, quick results, right? And you can experiment with it very quickly, right? So the baseline should be that base model plus training, evaluate it and repeat the process in case you are not getting the desired result. In case you have hit the wall, upgrade to the next bigger model, right? 3B, 13B, and so on and so forth, right? And you can also evaluate model distillation. What model distillation is? That you actually train your smaller models based on the output of larger models, okay? So what happens is, imagine a teacher-student kind of a relationship, okay? Teacher is the larger model, student is the smaller model. Whatever output the teacher is generating, student is actually just absorbing it, right? These kind of concepts are actually already provided in the third-party APIs, right? So if you want to try it yourself, like lot of talk, but if you want to, as a developer, try it yourself, obviously go ahead, read the license. Not every license is compliant with the enterprise level scale, okay? For chat interface, you can use D-answers, Open Web UI. Any guesses what you can use for LLM proxy, open source tech? Okay. So Cloudflare also provides AI gateways, okay? You have Light LLM technology, which is an open source technology you can use for the same. Knowledge base, basically what I talked about, the vector database. You have Chroma, you have Milvus. Milvus typically scales good, right? For smaller experimentation cases, you can use Chroma. For actually enterprise level usage, you can use third-party services like Pinecone as well, right? Again, this is not a recommendation. I'm just calling out the popular technologies, okay? Self-hosted model, has anyone tried Olama here? Right? So you can actually build your own enterprise solution by using Olama. You don't even have to spend ₹1 and talking to OpenAI, right? So let's get to the conclusion. I mean, we covered a lot of topics. Always build with reusability and observability and control as the core principle, okay? Because in an enterprise, things can get out of hand really quickly. RAG is simple, but it becomes really difficult when you are actually enriching the data properly, right? Train smaller models first. Effective prompts are really crucial. There is a saying, garbage in, garbage out. If the prompts are not good, you are not going to get the best of the results. And Gen AI is the future. Invest in it. PubMatic itself, till now, have achieved like the 10 to 15 productivity boost so far, right? And this I'm talking about last month's number. This month and December is actually yet to scale here. Yeah, so that's it. Opening it up for Q&A. Yeah, please. Can we pass on the mic?
Hey, hi, myself Parag.
Hi.
So want to understand in PubMatic what kind of use cases you are working on in terms of generative AI?
Yes. So there are two tracks that we have in PubMatic. One is the productivity track and second is the product track. Okay, productivity is basically empowering every employee, every product manager so that they can get their task done really, really quickly. So if a product manager working in ABC team, because they have an integration or dependency on some other team, they can get answers directly. So this is productivity track, which also includes like generation of code and other things. Second is the product track, wherein we are actually enhancing our product lines to use generative AI in order to kind of make sure that our valued clients are getting benefit out of the same. PubMatic being an ad tech, there are a lot of solutions requirements which actually comes in order to curate the inventory. So for example, if I am launching a new Nike shoes, which kind of audience should I go ahead and target, right? So it can ask some follow-up questions. So for example, which geography you're launching this particular shoes, right? What is the target audience that are you targeting runner, are you targeting jogger, or maybe some other thing, right? And based on that, it can actually go ahead and curate the inventory and then showcase it to the customer. That way the customer doesn't have to think much about which selections do I need to make, but they only think about, okay, this is my problem statement. And also it actually, if you think in terms of the user experience, you are not actually spending a lot of time in clicks. You are actually telling this is the problem statement. If you accept this answer, within one click, go ahead and call the API and it's done, right? So these are the use cases that we are implementing. Any other questions? I hope, yeah, please go ahead.
I have simple question about the measurement part. So you have billions of requests, what you mentioned earlier. So in this Gen AI, all the requests what you are serving from any of the models, so how are you measuring and evaluating that particular response is with respect to at par at your expectations kind of?
Sure. So I'll just correct one thing. So the billions of impressions, that is our ad tech platform, right? So not every request is actually being transformed through the Gen AI. Coming to more generic question that how do you actually measure the performance of generative AI, right? So typically there are different ways for different type of measurements. Example, productivity, if I take, right? I have to look at my velocity charts in order to figure out if the product managers are using the tools that we are providing them. Are we actually experiencing any increase in velocity or not, right? If not, then we have to go back and understand what are the reasons for the same, right? So it is really important in all the generative AI output that always also give the source in order to create the trust and always collect the feedback, right? Based on those metrics, actually we evaluate. In the model training pipeline itself, we have very specific inputs and outputs, desired outputs, right? The ideal outputs that we have, that we cater to, and based on that, we actually evaluate the entire pipeline. Okay, any other questions? Yeah, please go ahead. Can we pass on the mic?
Hello. Are you using open source LLMs or like a ChatGPT and Gemini?
Yes.
And,
Yeah, go ahead. Please.
Yeah, and also how are you doing a cost optimization for LLM? They're calling for it.
Sure. So definitely, that's a very good question. So we are using open source weights, as we call, right? Because as I told you that you have to take a base model, then train on top of it, right? So we use open source weights which are there for certain models, then train it out. And in order to do the cost optimization, so as I mentioned earlier, that you have to start with smaller models. So first we take that, let's say if I am getting GPT-4o mini response or not, in case I am using third party. And based on the feedback, as I mentioned, so for example, let's say I have given the required information as well as source to my developer, and developer is not happy. The moment they do a thumbs down on the feedback, again a call goes to the LLM, and at that point in time it selects a higher model, distills the lower model which was being used earlier, so that it can actually learn for the future and then return back the output. This way, actually, although we have spent more money on that particular request, but subsequent request we are actually going and training. That we actually optimize a lot for the cost. Plus, a lot of things depend on the inference engine. So for example, people have used Olama here, but if you use some different tech like VLLM, right, probably inference is faster on the lower resources, right? So you have to evaluate on those lines as well. Any other questions?
I feel
Yeah, I think we are out of time now. Yeah. I hope you guys have enjoyed the session, and we have a, thank you.